Hello, Anatoly. How are you doing?
Good morning, Constantine. Good. How are you?
I'm good. Thank you. Okay, wonderful. Let's let people a minute. Let's give people a minute to join and we'll start. Today, we're going to be covering vulnerability management with some practical insights.
Okay, sounds good.
Mhm. All right. I think we can start. All right. Let me share my screen real quick and we will go right from there. Can you see my screen?
Yeah.
Okay, wonderful. All right, so vulnerability management. It's how we call it. It's not a hard problem, but it's a complex problem. So you need to put many pieces together in order to establish a proper vulnerability management system inside your organization. And vulnerability management and the signals that it generates is probably one of the most insightful systems for GRC specialists because it gives us an it gives us a sense of how well our governance works. What are those type of security events that we are catching? What are those um, maybe even operational events that we can see that and what are those types of events not only that we're catching, but what are those types of events that we are reacting to? Do we have the visibility to all issues that our ecosystem has, or is it just partially implemented and we need more coverage? And vulnerability management, so that we all understand, is about okay, let me see, somebody wants to join. Lion, okay. Hello? Hello, Lion, how are you doing? Welcome to our session.
Hello, thank you so much. I'm good. How are you?
Good, good. All right, welcome to the group. And today we are going through the vulnerability management. What is it about? How it relates to GRC, how to establish proper vulnerability management, and how to operate it inside the organization, right? If you will have any other questions or topics you want to discuss, please email me or raise this question in our Reddit group, or watch videos on our YouTube channel at Full Stack GRC. Okay. So,
Okay, great. Thank you.
yep. To recap, vulnerability management is one of the central topics of GRC because it generates signals that basically tell us how well we establish the governance across operational assets of the organization. Quick overview for you, Lion, about what operational asset is, because you have not joined our previous sessions. Operational asset is like everything that the company owns or operates. It could be information systems, it could be buildings and facilities, it could be people, it could be any type of process like brand, anything that requires governance is operational asset from our perspective, from governance and risk management perspective. And vulnerability management stands there somewhere in between the user devices. Like we need to manage vulnerabilities in the devices that we issue to people. Then we need to manage vulnerabilities of our information systems, and information systems are consistent of multiple parts. Information system that we own as an organization is usually consists of a database, maybe even a data lake, some scientific processes which could be encoded as software. Then servers that it all runs on, or computers where it all runs, and the underlying infrastructure, so where it is hosted. And vulnerability management has to be established at all of those levels. And if we have any consumer-facing applications or software, we definitely need to manage vulnerabilities that that are related to the consumer-facing apps. So this session is more technical than the previous ones and more hands-on. I'll show you some examples here and there, but overall, it starts with centralized. So in order to establish the vulnerability management program, we need to, first of all, understand what type of operational assets we have, and we need to govern. And here I will be mostly leaning towards the information systems, applications, and software. And what type of vulnerabilities may be there, and how do we monitor them? How do we timely remediate them so that no one else finds and exploits them before we know? So if we talk about the application, let me share a screen real quick. Please let me know if you can see this diagram.
Yeah, we can see.
Yeah, so the software, we usually look at a single interface, and it's a mobile application or it's a web application or whatever, right? And we say, all right, so this application is most likely, it is our interface, how we interact with the app, right? But in fact, the software has multiple interfaces, and the issues that arise from that, whatever vulnerabilities each of those interfaces has, or the underlying software, or the underlying, by underlying software, I mean the backend, or the underlying infrastructure, right? It all can generate opportunities for the hackers to attack our systems, to break in and to damage our reputation mainly, and steal the data, and make a lot of damage to our customers or our employees. So whenever we talk about establishing the proper vulnerability management program, we first need to take a look, high-level overview at things that we need to vulnerability manage. Okay, let's call it this way. And it's all the application interfaces that need to be included here. It's all the middleware, and middleware software is like whatever helpful software our software runs to make to operate better, more efficiently, right? Then databases, whatever databases, data processes that we have, whatever system parts we have, like background jobs, scheduler tasks, right? That's what I mean here. Internal data synchronization processes and stuff. And what integration layers do we have in our applications that actually exposes our system to external systems, and also exposes external systems to our customers, or to potential malicious actors, to the hackers, right? Then The other thing we need to look at is and I'm giving a quick overview here, and another picture here is the underlying cloud infrastructure. If we host our applications in the cloud, right? So we need to see what we need to vulnerability manage here. And usually what we have is like, for instance, the servers or the virtual machines that we are running inside the cloud, right? Then some appliances, virtual appliances that cloud provider gives us, like application load balancers, or I don't know, the virtualized database servers, right, and other things. They all have to be vulnerability managed, because at the end of all, everything that we spin up, let's call it this way, every server that we spin up, or every service that we spin up or launch, we are responsible for, right? So it's the cloud infrastructure here. And the other thing that I will not be showing on the diagram, it's the end user hardware, like employees' devices. If we give our employees the laptops, they need to be vulnerability managed. If our employees are using cell phones, company issued cell phones, they need to be vulnerability managed. Literally, like everything it goes into here, into this, falls into this category, right? And for us to establish this whole governance across all these different types of things, we need to first identify those pieces, right? And we just did that. So we have the devices, we have the applications, we have databases, we have underlying cloud infrastructure or on-premise infrastructure, depending on where you run software in the organization, right? And then the first thing that we need to do is to establish visibility across all this stuff. And it's usually done through the centralized logging. So every server, every service, every application, every device emits a lot of different events. Like it starts up, it boots up, it shuts down, it has some lifecycle events where, you know, some if we let's say are building or have built the scalable cloud infrastructure, there will be scaling events, scaling up, scaling down. And all those events we want to actually, and then when we have users using our software, there will be multiple events associated with the usage of our applications. Like when the user logs in, the user requests this, requests that, and you know, things like that. And we want actually all the logs, all those events from all the appliances, from all the devices, from all the software, from all the underlying infrastructure, somewhere in one place. And it's a different story, separate topic, how to establish that centralized logging, right? But the cloud providers give us, you know, some tools for that, and it's quite good. And you know, the MDM, the device management platforms, give us tools to actually also capture logs from the devices. And of course, web servers and mobile application platforms give us insights at, you know, at how many users we have, what user requests are, and if our software development teams are doing a great job, then basically all those events that the applications themselves emit, we can also centralize and you know, and we actually group together somewhere on a single place, on a single dashboard. And this single place where all the logs come in is usually is called it's a broad name for it, and it's a little bit misleading, but it's usually called SIEM. And although SIEM is a security events management platform mainly, but people companies understand that establishing operational events management, and then security events management is not always an option, like to be separate systems. So they use one and use it for all. But the bigger the organization is, of course, the operational monitoring goes into a separate product or a system. It could be Prometheus and Grafana, it could be CloudWatch, it could be, whatever, Datadog, and others. And security events go in a separate, exactly the SIEM, which is usually, depending on how you build it, it's either custom built something on open source Elasticsearch stack, or it's a specialized system like Wazuh, Wiz, and others that you use specifically to triage security events. But anyway, if you establish centralized logging, you have you now have some at least understanding of how many systems you are monitoring, right? And all those systems need to be vulnerability managed at the end of all. And now we can get to the actual vulnerability management stack or foundations. So what we need to do, I'd say it separately, but it's a part of the vulnerability management program for sure. And it may not be, it actually will be centralized logged. It's the antivirus or anti-malware scanning of user-generated content. So whenever your applications or your software works with the consumers, and consumers are uploading data or into the platform, you need to establish antivirus scanning, because this is one of the easiest paths to hack the system, right? And in terms of vulnerability management here, we'll say, okay, the vulnerability management will mean that we establish that scanning and we update our antivirus databases regularly, right, as a part of the vulnerability management program. And whatever events the antivirus or anti-malware system generates, they go into the centralized logging platform or platforms, which is, we just identified the operational platform, the security platforms, the SIEM, and it could be one system or separate. And we can see those events, and we can actually then later act on them as a part of our incident response process. So the other thing is, if we have any servers, and most organizations, like all of them, have servers, either physical or virtual or, whenever, like it's like everywhere. It's like a mobile phone. The server you have. And for the server, you also need to establish the vulnerability management program. And it actually means that you need to log all events that the server generates, if possible. And then you need, similar to antivirus process, you need to establish the regular operating system upgrades for the server, because if you run the server in 2026, by 2027 it will but by the end of 2026 it will contain all outdated software, right? And operating system will be outdated. And if operating system is not well maintained by the maintainer, by the developers, then you're in trouble, because it opens up a lot of holes where the attackers can come from. But so for that reason, you need to actually establish and turn on the regular patching. And you need to patch the operating system itself. And then you need, but by receiving the OS upgrade, so the version of operating system, you want to make sure that it's always current, or at least not so far from current. And then it should be all the security patches that are being released by the operating system developer. Your servers should receive them as soon as possible, and that actually will do good, right? What I must say about the host patching schedule is servers are running, software servers are being used. So we should know as a GRC person, we should know that the team that is responsible for maintaining the servers, they should first of all establish regular patching. We should be satisfied with that. It should be in alignment with the regulatory requirements, if any. Let's say if the company implements SOC 2 compliance, we need to make sure that the patching happens at least once a month or whatever. If it's more regulated, like HITRUST or whatever, medical stuff, it will be different requirements, right? But we need to make sure that it's fully satisfied. But what I wanted to say is that it's important to establish a maintenance window during which all those servers will be patched. And we need a way to ensure that this patching has completed. And for that reason, using a system with or several systems for centralized logging, so we can capture those events and record them for audit from the audit perspective, for the audit reasons, is important. Then the other thing is, on servers we run software, and our software is usually in some cases extraordinary situations, or when it's a little bit when there are certain requirements for that. In some cases the software runs directly on I mean the company owned software runs directly on the server. Then we need to somehow establish patching schedule for that software, right? But if it's containerized and runs in Docker containers, we need to make sure that we get help from secure software development practices that we discussed in session 5 or 8, I believe, that the containers that are coming on the server are always updated with the most recent version of the base image itself. And of course, the application, the software version is also updated inside those containers. I haven't touched one other thing here in the server patching. Server runs multiple software that is needed for operating system to run, or a lot of different tools that are needed to support the company-owned software. For instance, it could be some third-party libraries or some video or audio processing tools like FFmpeg or I don't know, whatever it could be. So these are also require vulnerability management and must be patched regularly. And there should be transparency in that process. So together with patching the OS version, together with receiving all the security updates, we should ensure that all software, like those system processes and supporting processes that we run on the servers, they also receive timely updates. And it would be great if it's also reflected in the centralized logging system, so it's visible and auditable, right? Okay, so for the virtual servers, there is, as well as for the containerized applications, there is a base image. In case of the physical server, we have a box that we turn on, right? And it boots up and it's a server that we could use. If it's a virtual server, there is the software piece that is called an image that simulates the whole process. Like the simulates server start, booting, operations, and everything. It still runs on a physical box, but we don't have access to it, and it's like our own piece of virtual hardware, right? And this image that it launches from, it also has to always be. We also have to make sure that we're using the most recent version. So if we launch a virtual server 10 years ago and never updated it, it's kind of the same thing as turning on the machine, the actual physical server 10 years ago and never updated. And which means that basically it should be very easy to hack into it, like extremely, extremely easy to hack into it. Okay, so we just touched the topic of container rebuilds. It's for the company-owned software. Whenever the new version comes in, the container should be rebuilt. The base image should be picked up from the most recent. The most recent base image should be picked up, and this is how we ensure that at least we are running on the latest and greatest of the software, underlying software, let's call it this way. And the other thing is important to mention, and we'll touch it a little bit in a few minutes, is the OS hardening and container application container hardening. Hardening means that, and also we need to harden the underlying cloud infrastructure, and I will show you a diagram that that actually shows how to harden the underlying cloud infrastructure. Is this one, and we will definitely discuss it somewhere in the future in detail. But it's all those bells and whistles that go into hardening of the whole infrastructure, your cloud account, for instance, that runs your software. But OS hardening and application container image hardening is a little bit, it's just a small part of that big diagram, and we can touch it and discuss it today. Then, of course, as I mentioned, the word hardening. With hardening comes scanning to ensure that it's hardened and it works. And I will actually explain on that in a few moments. And we of course discussed the endpoint security and patching. It's about the company issued device, company managed devices. By the way, if the company is not issuing and is not managing the devices, at least we should somehow get the information into our centralized logging platform, into whatever dashboard that we have. The information that those devices are compliant, and people bringing their own devices are still following the company policies related to proper device hardening. Yeah, I'll call it this way again, because hardening means installing, turning firewall on, encrypting the hard drive, installing and regularly running the antivirus, and also all those things related to OS updates, security updates, and whatever software is running on the device should also receive updates as soon as possible. What I wanted to touch next is not the endpoint patching, because we just looked at it real quick. Let's talk about the vulnerability vocabulary, because it's kind of important to know. I'm personally not well versed in all those acronyms. CVE sometimes is the same for me as CWE, but in fact they are different. And I'm not usually so usually very easy to understand what this means in a context of whatever, in some context. So CVE is the common vulnerabilities and exposures. It's basically the number that vulnerability is given when vulnerability is identified. Same, for instance, I'll give you the medical kind of. It correlates with the medical field. When the new virus is found, like, and we know that it's a virus, let's say, of COVID, because we had COVID like a few years ago, right? So we remember that. It has a number, right? Every mutation of it has a number, and this is basically the same as CVE here. So the vulnerability basically is a weak place in software, right? It has a number, and it's numbered. Then there's a year, and then whatever sequential number that is assigned. And when we see CVE, I usually don't pay much attention to the years and numbers. Well, let me be honest. I pay attention to the year, but it doesn't give me enough information to know whether it's recent or happened earlier in the year. Whenever you see the new CVE anywhere, pay attention, read about it. It may be an interesting piece of information, and it's because AI now uncovers CVEs. Like there are days or weeks in a month when, if previously we were receiving like a few CVEs a month or a week or a day, now it's this number is 100x, like factor of that. So if we receive, let's say, one CVE every hour in the past, now we receive 100 CVEs every hour. Okay, so CWE is the root cause. It's basically the description of that CVE. So it should be easy to remember. CVSS is something to pay attention, very much attention to, because it's a score or severity of that vulnerability. So if you see the new CVE number somewhere and you see it has a severity of like a CVSS of 9 or 10 or 8, it means a bad thing. You better pay attention and actually read about it more. As a GRC specialist, I find it very useful. So they pop up in LinkedIn feeds, they pop up in news articles, they pop up in, in all those media, in social media and everywhere. So you, one way or another, you will hear about them. And that's what I do. My regular practice is what I do is when I come across a CVE, I'm not a nerd. I'm not scrolling the CVE database trying to, to see the new things like every minute or whatever. But when I come across a CVE that I think is interesting, first, and I understand that the score is high. First of all, what I do, I go back to the teams that I work with and say, hey, let's look at this one. Maybe it applies to us, right? And if it does, it's time for the ad hoc patching, right? Security patching of the systems. And what is great about AI right now, I implemented a small AI agent that was actually monitoring my social media feeds, and it started bringing me the CVEs. And I believe that under the hood, it was Claude. I understand it so that because these AI models are developed by the tech companies, they're mostly experienced in coding, and every other technical aspects, technical things, right? So it's like natural for it to detect and bring the CVE if there is one. And it actually brought me some CVEs, and it actually patched some of the servers for us. So yeah, but I wanted to stop on that. And here we go. Another thing is EPSS. It's the probability score that a certain CVE, or the vulnerability, will be actively exploited in the next month. I don't know how they do this prediction. It's good to pay attention to it. So this may actually increase a sense of urgency for us, right? If we see that EPSS is high, so probably it's something that we need to patch real quick. Okay, so the establishment of the vulnerability management program starts with the foundation. We discussed it: the centralized logging system, antivirus scanning of user-generated content, server patching in many ways, right? Application containers and application patching in many ways. Patching of the OS images for the virtual servers, and endpoint security and patching, right? What did we not cover? The underlying infrastructure patching. So when I share this, when I show this diagram to you, this this session actually covers only the devices, the company-owned software, and what else? And some pieces in between. I mean, the software, the software infrastructure, and the underlying cloud infrastructure. But what it doesn't cover the underlying cloud infrastructure services or other services that we may be using. So sometimes you use a service within your cloud provider. Let's say if you're sending text messages to your customers through the app, you're most likely using the SMS or text messaging system inside your cloud provider, AWS, GCP, Azure. But sometimes you can use a third-party service, which is like Twilio or whatever, to do the same. So we should know as GRC specialist. I mean, and it's all. I'm trying to look at all these things from a high-level perspective, usually and always. As GRC specialist, for me, what's most important here is the level of responsibility. So when we use the cloud services, and it's our own cloud account, there is a shared responsibility model. Cloud provider says, okay, we are responsible for the virtualization systems and the actual physical boxes and the data centers and everything. We give you that, and then it's your responsibility. So for us, it's our responsibility, right? To if we use that service that sends text messages, for instance, it's our responsibility to harden it. Hardening is not only patching, ensuring that the security patches come in and the underlying operating system version goes up. Patching is also vulnerability managing, things like that, is ensuring that it's not open to the public, that we are not using this service with the old version of software development kits. That, you know, it's like it's a multi-aspect thing, and we should know how to ask those questions to the development team, to the DevOps, or those who are responsible for the cloud infrastructure, or who are responsible for the CI/CD process, like, which is in between. We know we need to actually. The reason I'm saying that is because we always should search for a perspective that best that helps us actually contain that issue and then start worrying about it, and then properly communicate it to people, and ensuring that it's protected. So when I go back to here and say we need the centralized logging system, how do we ensure through the central? How do we ensure that, let's say, the developers are using the most recent version of software development kit to access the text messaging service inside the cloud environment, right? The logs should show us. We should understand, okay, how are they doing it? They build software, they write software. The software interacts with this text messaging service. Then there should be some sort of a code library or development kit that is helping them with that. It's a third-party library, it's not our own. So another good piece of the VM Foundation, Vulnerability Management Foundation, it's also establish monitoring across security patching of those third-party code pieces, right? So, and then it all rolls up. It all aligns, actually. So our developers are writing code, whether AI-assisted writing or the old way with hands, right? Which I no longer believe in that anymore. But we know that they are producing high-quality modern code. Then we need to ensure that they are using the modern and high-quality code libraries to access the service, and then the service itself inside the cloud environment or in the external provider is up to date, because it's not always detectable and visible, but the text messaging service that we are using, and we're thinking, okay, it's just a text messaging service, and AWS or Azure will take care of it. But then the email comes in from Azure and says, hey guys, you need to push that button actually to migrate your text messaging service from this version to that version. And this also goes back to the vulnerability management process. Immediately becomes our issue to work on. And we should start monitoring it from that moment in time, realizing, okay, we are not using it just as, as pay-as-you-go stuff. We have to watch for it, because we are responsible for upgrading versions inside that service. These things are quite common. Okay, so what are the other things that I wanted to cover? These we discussed. Patching, virtual patching. Yeah, okay. Code fixes, risk acceptance, compensating controls. It all actually can be derived from what we discussed, right? Then let's quickly touch the SLA framework. So once we establish the vulnerability management program, let's say all the servers are being updated, we ensure that at all layers everything is updated and patched and secured, that everything is scanned, that scanner results are available, that we can that we now have all those signals, right? What's the next thing for us to do is to switch from vulnerability management foundations to actual operating vulnerability management program. An operating vulnerability management program means we should start correlating those events. We should establish a process of triaging those events and reacting on them. And it goes back to our incident response process. It goes back to our SLAs. So depending on, it's now not only the, let's say, the login it's not only the privilege escalation events that we are monitoring here, or unauthorized login events. We are now in it all goes in the same bucket. We're now monitoring the vulnerability related events, right? Like OS patching, application container patching, scanning, and stuff like that, in the same way as if they were the actual incidents, right? Or we call it security events. It all goes in the same category. And it should be treated equally as any security incident. All those signals that were received from vulnerability management program that we established, they should have, all those events should have different severity. For instance, quick example, patching the customer-facing server is much, much more important, right? And it's like, I'd say it's a critical thing to do than patching, let's say, a desktop computer that stands somewhere in the corner of whatever the office that nobody comes in, and they turn it on once in a year just to get a report. I mean, it's equally important to patch it, but the urgency is, it's different. So it's like a medium priority. It's never a low priority, by the way. I mean, the low priority event is rare, and we should be conscious when we assign something a low priority. The reason being, any event that we receive in our systems and our dashboards, they may look low priority, but in fact, they may open up a can of worms if they're not addressed properly and timely, really quickly, right? So, yeah, and I just want us, to show links here. So we establish the foundation, we send all those vulnerability management events into the same bucket, into the same dashboard or the system that we would send the operational events, the other security events into, and we treat them equally. We triage them, we assign them priorities, we understand what's critical, what's not, and we go through there, right? Okay, so the other interesting thing, there are certain things that we can monitor continuously, or these are the processes that we run by timer, by schedule. But other things are, but other events can be coming from external, at manually ingested into our systems, or even provided as a separate document, that we should also somehow find a way to integrate with whatever automated, I'll call it, whatever automated dashboard that we already have. And usually the penetration testing reports come in as PDFs, and this PDF contains some, at least some vulnerabilities that need to be remediated. And I don't have a right on top of my mind a good solution for automating this intake, but with AI you can actually parse the PDF, find those vulnerabilities listed there, and ingest them into the centralized logging system, the SIEM, so they become visible to the incident response team, and they will then reassign those to the software developers and make sure that it all goes through the process, right? But again, I just wanted to highlight that some vulnerabilities are not coming automatically to us. And until you establish full governance or full automated way of collecting vulnerability management program related signals, you will be doing a lot of manual work, right? We touched incident response process previously, so we understand how to handle security events based on criticality and things like that, so I will not touch that. A few things I wanted to show you regarding hardening. We touched that, but I did not go deeper into that subject. And what I will do now is I'll show you a different screen. And I'll show you a visual of how hardening looks like real quick. And what it, on one example, because, okay, but let me share it first. So if you can see my screen here, I'm using a system. It's one of the SIEMs available in the market. This one is open source. And through it, I can manage the security events that come in. And also I can manage the vulnerability management stuff that is necessary. So here I show you the hardening procedure that we implement for the virtual server. Our virtual server is this one. Its name. Of course, it's ephemeral. It spins up and then goes down based on automatic scaling and things like that. So we don't give it any reasonable name. So the server was created from a security patched image, OS operating system image, and but it was a base image that Amazon provided, AWS provided. And then on top of that, as soon as we launched, well, we took that image, and inside AWS there is a set of tools that we could use. And it's called the Image Builder. So basically, you take a base virtual machine image, and you can apply whatever patches you want on top of it. So to get it to the desired state, for instance, you can pre-install some software, you can implement security patching, blah, 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 blah. So when this server comes online, it already has everything you need from it, right? And for the purpose of our conversation here, this server was security patched through the image builder process. And its original operating system, Red Hat Enterprise Linux 7, and we applied a number of security patches, like we ran them sequentially inside the image builder. And Wazuh helped us to actually then evaluate the actual hardening. And we call this procedure hardening because we are eliminating, through those patches, we are eliminating security holes inside this virtual machine, right? We're closing ports. We are applying some kernel patches. We're applying some known security patches to vulnerable software that comes together with this version of Red Hat and things like that. And then as we applied those patches through the AWS Image Builder, Wazuh noticed that this server came up at one point in time and executed what is called the benchmarks, basically the security scan on it, and provided us with a report. And you can see that the security score of this instance is 98%, which is quite good. There is only one failing control, right? I must say it was not a one-day exercise for us at the time. CIS, please remember this name, is Center for Internet Security. It's an organization that actually develops those benchmarks, and they evolve them, they improve them. You can always go back to them, download their PDF report on the benchmarks, or pay them and download the automated scripts to check, your servers. What is good about them is they are an active maintainer of those benchmarks. So whenever the new operating system version comes in, you can always download the new version of CIS Benchmarks for it and ensure that whatever hardening procedures you apply to your hardware or even virtual hardware, you can actually see the result of your efforts. The result of our efforts here is 98% hardening successful, I'd say, right? There's only one failing control, and that one is, let's find it here. IP forwarding is disabled. Yeah, so it's the system level stuff. I remember, I don't have a quick overview of that. I remember that at the time we discussed it thoroughly with the DevOps team. I asked them why this one we can allow ourselves to keep in a failing state. They explained to me, their explanation was confirmed through my research, and it's satisfactory. So with this particular server, which is not customer facing, blah, 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 this control, the failure of this control is acceptable. And we remember then whenever we say there are, let's say, 10,000 controls, and we accept 2,000 of them as failed, how we call this situation? We call it the risk appetite. It's our risk appetite. We are ready to risk this control because we know that it's not damaging to our systems, right? I just want to link some terms here and there for you. Okay, so the other thing I wanted to demonstrate is one security event that came from that same system, Wazuh. Let's review it real quick. All right. Let me see if I can, if I'll be able to share it. Let me know if you can see it. Yeah, so it goes to operations, right? It may be the vulnerability management related event, or just the attempt to break into the system, or anything. So here was the attempt to log in using a denied user. It's not in scope of our discussion today, but what I want to say is that it's the same system, right, SIEM, that we're using to monitor the hardening and the vulnerability management practices that we establish, and also all the security events that go inside our cloud environment. And this is the centralized place for our incident response operators to view those events, triage them, assign criticality, and handle them properly, right? The other thing is, and the other thing I wanted to show you, which also is outside the scope of this conversation, but it's about the same concept. Let me open it up real quick and share with you. Just a moment. It takes a second to find the screen. I don't see it yet. Give me 1 second. Here we go. Okay, let me know if you can see it. So originally, it shows the yeah, if you can see it, great. It shows the penetration test report, but this penetration test report is not a PDF document. It's let me tell you what kind of transformation happened to get it in this way. So what I want to say here, the biggest message that I have is that we should aim for ingesting all vulnerability management, security, operational data into the same system, or if you maintain two systems, into those two systems. So basically, we want all observability across all our operational aspects in those systems that we actively monitor. And this screenshot shows that our penetration test report is now a part of our the dashboard that we use for all those other types of events. So not only the host hardening or the server hardening exercises we can see the results of, not only the security events, not only the operational events, but also those things that come from the external, we see it inside the same system. And now how we got there. We when we first received the penetration test report for our software from the pen testing firm, we looked at it. It was a PDF document with vulnerabilities listed, as I mentioned, right? And I looked at it and asked myself, hey, how can I automate it? How do we convert that document into something that we ideally could run not once a year, but more frequently, like for instance, every quarter or so? How can we get it into our dashboards that we use for operational and security monitoring? And I went back to that firm and said, hey, you ran a series of tests. You ran it through scripting, right? You have software to do that. Let's see what tests were executed. Let's put them in, let's convert them into a piece of software and give us this piece of software. So we will be running it against our systems going forward. And whatever events it produces or reports it produces, the vulnerabilities it finds, findings it produces, we'll ingest them automatically. right, into our operational dashboard. And this is what happened. So now we have, like, you can see that instead of receiving like 3 vulnerabilities listed in a single PDF document, we now know that we are running 111,000 of tests here, 40,000 of tests here, 40,000 of tests there. And it's a big effort, big exercise. And we only get like 2-3 vulnerabilities from it. We're doing great. If we're getting 100 vulnerabilities, we're doing worse, you know, and it is actually a great way of establishing that governance, that what this GRC is for. Okay. All right. I think it was everything I wanted to show. Do we guys have any follow-up questions?
No, thank you. Everything was clear.
Sure, great, wonderful. Please feel free to ask questions on Reddit, via email, or any how else you want. You can comment on YouTube videos. I would appreciate that. And guys, thank you very much for attending. I hope it was helpful for you. And please have a wonderful weekend. And I hope to see you next week on our next session. See you guys.
Thank you. Have a good day. Bye.
Bye-bye. Thank you.